Hey everyone! In this video, we're going to be taking a look at how to find the derivative of the inverse tangent function. So we're going to begin by deriving the formula that we're going to use, and then we'll use that formula in an example. So to start off with, let's say we have an equation, we have a function, and let's say it is y is equal to the inverse tangent of x. And we want to find the derivative of this. So to begin, if y is equal to the inverse tangent of x, that is equivalent to the tangent of y is equal to x. So we want to start by making this switch because we do know how to find the derivative of just regular tangent. So let's start by taking the derivative with respect to x of both sides. So we are going to find the derivative of this equation using implicit differentiation. So on the left-hand side, we have the derivative of tangent, which we know is equal to secant squared. So we have the secant squared of y. And since we are taking the derivative with respect to x of an expression that has a y in it, we do need to include dy over dx. And on the right-hand side, the derivative of x, this is just equal to 1. Solving for dy over dx, what we end up with then, we get 1 over the secant squared of y. So this is actually the derivative of the inverse tangent. However, we are left with an expression that has a y in it. We do want this formula to be written in terms of x. So we need to find a way to substitute out the secant squared of y. In this case, it's relatively straightforward. So remember, one of our Pythagorean identities, the secant squared of y is equal to 1 plus the tangent squared of y. So we can substitute out the secant squared, but if we do that, we will be left with the tangent squared of y. However, earlier on in this process, we did say that the tangent of y was equal to x. So I can rewrite this, and I can say the secant squared of y is equal to 1 plus, and now instead of tangent of y and then squared, we can substitute in x. And then what that gives us, so the derivative of the inverse tangent is going to be equal to 1 over 1 plus x squared. And this is the formula, this is the rule that we want to use to find the derivative of inverse tangent. So now that we have that established, let's use it in an example. So here I have y is equal to the inverse tangent of 4x. So let me just rewrite our rule. So the derivative of the inverse tangent, so dy over dx, is equal to 1 over 1 plus x squared. And now taking a look at our equation here, I am going to have to use the chain rule because inside my inverse tangent, I do have a 4x, so we're going to have to use the chain rule on this. But our derivative, so using the chain rule, we'll take the derivative of the outside first, which is our inverse tangent function. So the derivative of that piece is going to be 1 over 1 plus. And now instead of just x squared, we are going to include everything that's in parentheses. So that's going to be 1 plus 4x squared. That takes care of the derivative of the inverse tangent part. And now the derivative of the inside, so the derivative of 4x, we're going to multiply by just 4. And to finish up, to simplify our derivative, I'm going to move the 4 into the numerator. So we get 4 over 1 plus, and then 4x, taking that quantity and squaring it, we get 16x squared. So here's how we find the derivative with a combination of our new rule for the inverse tangent along with our chain rule.